Good evening. Yeah, so we are live. Please tell the rest that we are live. Invite them right now. We are live, guys. All right. Good evening. Good evening, everyone. If you can hear me, comment. I can hear you. Good evening. If you can hear me, see, I can hear you. While waiting for others to join, let me know. Good evening, guys. If you can hear me, please comment. I can hear you. If you can hear me, please comment. Can hear you. Okay. A lot of you are saying you can't hear me. If you can hear me, please comment. I can hear you. All right. So if you are, please, the only thing you can do to be a bona fide member of Jaex Academy is to subscribe to this YouTube channel right now as we are about to kick off. Now tonight, our primary focus tonight is to look at nomenclature, the naming. That break. Good evening, good evening. So sorry for the break. I'm back. Can you guys still hear me? Please comment if you can still hear me. I'm back, guys. Please comment Yeah, good evening, Divine. Good evening. I see you. Yeah, Tina, good evening. So please comment if you can hear me. See, I can hear you. If you can hear me. All right. Emmanuel, Guna, I see you. Victoria, I see you all. My network is a bit unstable, so bear with me, guys. I'm not in my usual spots. So tonight we're gonna do nomenclature. Tonight we are going to be looking at the naming of organic chemistry. So if you are ready to name organic chemistry, just comment nomenclature. Comment nomenclature. Comment nomenclature. If you are ready to name organic chemistry, yeah, keep it rolling in. Comment nomenclature. Alright. Now, the reason why I'm always doing this call and response is to ensure that you guys are hearing me, that I'm not talking to myself, and I'm glad that few people are able to comment nomenclature. And yeah, blessing, I see you. Okay, so tonight, like I said, we're going to be doing the naming of organic chemistry, and that is nomenclature. So if you are new here, please subscribe to this YouTube channel. Now let's go. So if I are new, you are subscribe to this. Now there are rules in naming organic compounds. So if you don't understand these rules, you're going to be lost. So I repeat, there are rules in naming organic chemistry. If you don't understand these rules, you'll be lost, you'll be confused, you will not know your way around them one after the other. These rules, we're going to be looking at them one after the other. Let the continuous um, carbon chain, right? And this continuous carbon chain, longest continuous number of carbon atoms it contains. So I repeat, the first rule is to identify the longest continuous chain. Identify the longest continuous chain and name that compound according to that name. Can you guys hear me? Yeah, the network is a bit frustrating. Can you guys hear me? Can you guys still hear me? Hello, can you guys hear me? Hello, can you guys hear me? Hello, can you guys hear me? Hello. Please, if you can hear me, comment. I can hear you. If you can hear me, comment. I can hear you to ensure that I'm not talking to myself. If you can hear me, comment. I can hear you to ensure I'm not talking to myself. All right. So please, yeah, yeah, okay. So before we continue, let's inform others that we are back. Please inform them all that we are back. Please inform them all that we are back. We are back, guys. So sorry about the network. Um, but why are some people saying they can't hear me? So, um, if you're new here, like I always say, do it. Subscribe to this channel. All right. These old networks that are just demoralizing me. Okay, let's move forward. So, ladies and gentlemen, we are talking on organic chemistry. So I would say in organic chemistry there are rules for naming organic compounds, right? And we say that the first thing we'll do is to always select or recognize or identify the longest continuous carbon chain. Now the longest continuous carbon chain becomes the parent name of the compound. Now I was not saying that one is called melt, okay, and two is earth, right? And 3 is prop. There's sun, there's sun. There's sun, please. Okay, so 4 is known as boots. 5 is known as pet. 6 is known as X. Then 7 is known as Eft. 8 is known as Ot. Then 9 is non. D is deck. Right? So what I normally do, what I normally do, I used to recite one acronym that says Mama Ejiro, Mama Ejiro plug big plantain. Hilary Ansi Ochuko know the house. Now M, which is melt. E, two carbon atom is earth. 3 is prop. 4 is bot. Then 10 is deck. Now you can see, right? Now before we move forward, let's let's see. Let me try to represent all what I just said. Now, if we have a carbon atom such as this, right? Now, the first thing to do is to identify the longest. Now, if you can see my screen, please tell me how many carbon atom is here. If you can see my screen, please tell me how many carbon atom is here. If you can see my screen, tell me how many carbon atom is here. All right. So that means you guys can see my screen better. Okay, I see you. Now moving forward, let me just quickly clean it. Okay, so um now let me quickly clean it. Now, if I have something like this is a met, right? Now, I can say the compressed form of this guy is CH4. How many of you understand? This is, I repeat, this this thing is equivalent to this thing. So what is the difference? What is the difference? This one is an expanded form, then this one is a compressed form. Are we still together? Are we still together? Okay, Joy said I understand. So we said that um this thing you can see here, right? This thing you can see here, C is the expanded form, then CH4 is the compressed form. Do we understand that? Okay. So yeah, Faith said they do understand that. Okay, so let's move forward now. Now, moving forward, let's look at this um carbon. Now, what is our rule number one? Our rule number one said select the longest continuous carbon chain. That is, identify the longest continuous carbon chain, and that will now become our what? Our parent's name. Now, how do we identify this? How do we understand, or how do we identify this longest parent chain? So the first thing to do is to count. So let's say I want to count this. This is one. This is two. This is three. Okay. Let me count it under. So let's say this is one. This is two. No. No. So this is one. This is two. This is three. This is four. This is five. This is six. This is seven. All together. Now I can decide to count. I can decide to count this again today. One, two, three, four, five, six, seven. Now, how many of you understood what I just did? I counted up and down. How many of you understood what I just did? Please let me know so that I can go over it again. How many of you understood what I just did? Let me know, guys. So we are trying to identify the longest parent chain or the longest continuous chain, right? So we just counted to identify the longest. Now, okay, you all agree that you understood. Now, my question to you now is what is the longest continuous chain? Answer. And what is the longest continuous chain? Please answer now. Let's continue. Answer. What is the longest continuous chain? If you did understood what we just did. I'm waiting. My mic is on. My animated style. My mic is on. My mic is on. Okay. For the sake of those that say they don't understand, I'm going to repeat it again. So let me repeat it again. Yeah. Yeah, let me repeat it again. So let me repeat it again. Now, for those of you that don't understand, if I have a compound like this, hello, if I have a compound like this, now, what is rule number one? Rule number one says select the longest continuous carbon. So the first task that we are given is to always identify the longest continuous carbon, right? How do we go about it? It's simply to count. So we have up and down. We have up and down. Let's try to count. So we have one carbon atom, two carbon atom, three carbon atom, four carbon atom, five carbon atom, six carbon atom, seven carbon atom, four. Done. Let's count from off. One, two, three, four. We have five. We have six. We have seven. So anywhere we count, anyhow we count is whether we count one, two, three, four, five, six, seven, or we count one, two, three, four, five, six, seven, either up and down. Anyhow we count it, it shows that um 7 is the longest. So if 7 is the longest, what is now the name of 7? Now, according to this rule, 7 is known as hept. 7 is known as hept. Are we still together? 7 is known as hept. I repeat, this CH4 is the same thing as this is the compressed form of methane, right? So we now look at this guy. We identify what we did here is that we try to identify the longest continuous chain, right? And we said that the longest continuous chain, whether you count up and down, is 7. All these are just branch. Are we still together? You guys are going to be naming shortly. Now, moving forward, let's now look at the second rule of naming. The second rule of naming is that we should identify the functional group in the compound. Now, when we talk about functional group, we are either talking about single bond, right? Or we are talking about double bond, or talking about triple bond, or we are talking about the OH group. Now, when we talk about single bond are called alkane. When we talk about double bonds are the alkenes. And when we talk about triple bonds are the alkynes. Then lastly, alkanol ends with OH. Like when we did introduction to organic chemistry, we said alkanols are the same thing as alcohol. I hope you guys still remembered. Now, moving forward, let's see this. Note, whenever alkane loses one atom of hydrogen, an alkyl group is formed. So we can see, supposing we have H here, this would have been a methane, right? But what happened here? It loses one atom of hydrogen, and because it loses one atom of hydrogen, a methyl group is now formed. Now, this is supposed to be ethane. It loses one atom of hydrogen. Because it loses one atom of hydrogen, an ethyl group is formed. The same thing with this. Do you guys understood what I said? I said note, whenever alkane is losing one hydrogen atom, right, an alkyl group is formed. Do you guys understood that? All right. So let's now dive in now. Okay, so since we look at rule 1 and rule 2, let's try to use rule 1 and rule 2 to name these compounds first. Are we together? Let's try to use rule 1 and rule 2 to name these compounds first. So we'll combine rule 1 and rule 2 to name this compound. Alright, so if you cannot see me very well, please zoom your phone screen. Now, we have a compound here before us, right? The first thing we'll do is to count the carbon atom, the number of carbon. So here, when we count the number of carbon or the carbon atom is 1. Because it is 1, we'll call it met, right? So because it is 1, we call it met. Now, the second thing to do is to identify the functional group. Now, what is the functional group? It's simply saying, is it a double bond? Is it a single bond? Now, of course, we can see that it is a single bond, right? You can see that it is a single bond. Because it is a single bond, we know that single bonds are akin. Single bond are what? Akin, right? Now, if we combine A, what is A? If we combine A, what is A? Count the number of carbon atoms, which is 1, and it is met. So A is met. What is B? B is the functional group. What is the functional group? The functional group is akin. Now, if we combine these two together, A and B together, we have methane, which is known as methane. Do you understand that? Do you understand that? So if we combine the functional group together and the number of atoms together, we have met. Then the functional group, the ending, which is in, combining together, we have maintain. Do you understand? Okay, Kingsley said, I do understand. Here's a 2K. I know that many people went to sleep because uh, the network was unstable earlier. All right, so you do understand. Now, let's go to number 2. Let's go to the other one. Now, this is another one. Remember, what is the rule? The rule is to identify the number of carbon, right? So right now, let's count the number of carbon. We have 1 and we have 2, right? Now, number of carbon here is 2. And what did we say? If it is 2, we said it is Earth, right? So, because number of carbon, it is 2 here, we said it is what? Earth. Now, the next thing to do now is the functional group. What is the functional group? Now, in this case, we said that whenever you have OH, okay, let me use another color. We said whenever there is an OH group, whenever there is an OH group, right? So this OH group is an alkanol, right? So now let's combine let's combine A and B together. You see that A and B is ethanol. So this is ethanol, ladies and gentlemen. So this is how you name. Firstly, count the number of atoms, carbon atoms, or the longest chain. Identify the longest chain. The name, is it het? Is it pet? Is it hot? Is it non? Is it deck? Is it met? Is it het? Is it boot? Is it prop? So identify it first, right? When you identify it, the second thing you look out for is the functional group. All right. So let's do this. Let's do this. The next one. The next one. Now, if you guys understood everything I just said, right? If you guys understood everything I just said, can you try to name this one, or should we name it together? If you want us to name this one together, please comment. If you want to try, comment as well and say you want to try. Let me know, guys. Let me know. Do you want us to name it together, or you want to try? Try and give me the name. What do you want to do? You want to try? You want to try? Okay, that's the spirit. So just remember, use rule 1 and rule 2. What is rule 1? Try to identify the number of carbon atoms, right? The longest. Rule 2, identify functional group. So let's go, let's go, let's go, let's go. All right. A lot of people are saying they want to try. Oh yeah, whip and come. Whip and come. Somebody said it's 2 meter ezine. Okay, someone said it's ezine. Someone said it's ezine. Someone said it's ezine. Okay, okay, okay. What about Kingsley? Someone said it's Ez. All right. I feel you. I feel you. Okay. All right. You are doing well. I love that. I love that. All right. Okay, let's analyze this now. Let's analyze it. Yeah, you guys try. Let's look at this now. Right? Now, the first thing we will do that we said we will do, we agreed that we'll do is to identify the longest, right? So let's count now. What is the longest? What is the longest? Now, if we count from here, let's say 1, 2, 3, 4, 5, and 6. Right? Let's count from top. We have 1, 2, 3, 4, let's say 5, and 6. Right? So, ladies and gentlemen, whether we count from up or down, it is the same thing as 6, right? So let's use down. Let's use down. So firstly, we just counted now, right? We counted, and what we counted, what do we have? We have, so we just counted, and what we counted um six six carbon atoms, and 6 carbon atoms is known as X, S, right? S. Now, what is the functional group? What is the functional group? The functional group here is alkane. Why is alkane functional group? Because it carries one bond, right? So therefore, if we combine um, X and alkane together, we get enzene, right? We get enzene like this. Do you guys understand? Do you guys, are you guys still together? So if you say this is enzene, there's no problem. You're trying. Hello, you're trying. Now, so this is enzene. What I actually wanted you guys to do is to just give me the longest continuous chain, and it is enzene. Right? Now, moving forward now, note when counting a carbon atom, start counting from the side that is closer to the functional group or substituent. Now, when we say substituent, anything that is attached, anything that is attached to the carbon atom is called a substituent. Anything that is attached to the carbon atom is called a substituent. Now, earlier we said that when alkane, this is alkane, right? We said when alkane loses one hydrogen atoms, it becomes it becomes alkyl. Now this is methane. When methane loses one hydrogen atoms, it becomes methyl, right? It becomes methyl. It becomes methyl. So you can see that is it's actually it lost one carbon atom. So if we want to name this, we've already gotten the parent's name to be enzene, right? We've already gotten the parent's name to be enzene. So the next thing is to identify the substituent. But when you are counting the substituent, ensure that you are counting from the side that is nearest to the end. Now, if we count 1, we count 2, we count 3, we count 4, right? We count 5. You can see that we count 5. We can see that if we count from this way, right, from right to left, is farther. The position of meter is farther. But if you count from left to right, you see that position of meter is nearer. So therefore, I can say this is 2 meter. What I'm simply saying is that meter is at the position of 2 meter is in. Now, do you guys understood what I just did? So, like what I just explained, this is 2 meter is in. So, if you don't understand, let me know. Comment you don't understand. If you don't understand, please comment you don't understand. If you don't understand, please comment I don't understand. Let's go over it again. Because you guys are going to name the next one for me. Alright, let's go over it again. So I'm going to take off. I'm going to take off this from my screen. Right. I'm going to take off this from my screen. So I said, what is our row 1 and row 2? Our row 1 and row 2 says that first identify the longest carbon atom, right? And we all agreed that the first thing we do, we count to know the longest. So we say this is 1, 2, this is 3, this is 3, this is 4, this is 2, this is 4, sorry, 3. This is 5, and this is 6. Now, if you want to count from the outside, is 1, 2, 3, 4, 5, and 6. So I said, now we've seen that whether you label it from bottom or from up, 6 is still 6, right? So let's get rid of the up. Now we've gotten rid of the up. Now we see that the longest chain is 6, right? So we come to the table. If the longest chain is 6, what is 6? Now 6 is a zine. Sorry, 6 is x. 6 is x. Let me get rid of this. So 6 is x. So since 6 is x, what do we do? Since 6 is s, what is rule number 2? Rule number 2 said identify the functional group. Now the functional group here is a single bond, right? Single bond, we agreed that single bonds are arcane. Where are you? So we agreed that single bonds are arcane, right? Single bonds are arcane. So Because single bonds are arcane, what we now have is A. What we now have is A. 6 is X, which is 6 carbon atom. What is the functional group? Functional group is arcane. So when you combine A and B together, we have X in. We have X in. Are you seeing X in? So that is why the parent's name is S in, right? Now, there's now an additional information. The additional information says that what we have is substituent. Now, a substituent is like an attachment to this chain. Now, I now ask you, in this chain now, where can you see? Use your eye now and look at it. Where can you see and tell me that, uncle, this is an attachment? Look at it very well. You say at this number, right? You say at this number, we can see that this is the attachment. Because it is the attachment, it is known as the substituent. Now, we agreed in one of our slides. We said that, let me look for it. We said that whenever an alkyl loses hydrogen atom, it becomes alkyl. So whenever alkane loses one hydrogen atom, it becomes an alkyl group. When I remember, now look at this. Now this is supposed to be a methane. Supposing we have one here, right? It's supposed to be a methane. Supposing we have one hydrogen there, but there's no hydrogen. Now because it is three hydrogen, it is known as methyl, not methane, and it is the compressed form of methyl is CH3 on a CM. Now let's now go back to this place. Let's go back to this. I'm explaining it now. Very dark nose. Now let's go back to this place. Now, if you look at this branch very well, you see that this thing can be written as CH. The compressed form of this guy is CH3. Because it is CH3, it is called methyl, right? It is called methyl. Now, the next thing is now to identify the closeness of methyl to the end of the carbon chain. Now we can count from left to right, and we can count from right to left, right? So we've counted from left to right. We said 1, 2, 3, 4, 5, 6. Now from right to left, we say we have 1. Okay, let me change the marker now. Let's say from right to left, we have 1, we have 2, we have 3, we have 4, we have 5, right? And we have 6. Now, let's look at this now. At position, for the up, position 5, position 5. For the bottom, position 2. And I ask you, which number is the biggest and which number is the smallest? You will say, of course, 2 is the smallest, right? 5 is the biggest. Now, the rule says when you are considering a substituent, in the parent carbon, which is the longest chain, always use the smallest number. 5 and 2 indicate the position of methyl. If you count from the upside, position 5 is the position of methyl. 2 is the position of methyl. So I now ask you, which of them do you think is? So you always count from the side that methyl will have a smaller number. And if you want to do that, that will be position 2. Are you seeing it? Position 2. So therefore, I will say this is 2 methyl. I'm saying that methyl, it was enzene we first of all did for, right? Before we proceeded. Do you guys understand now? Please let me know. Do you understand now? Do you understand? Do you guys understand? Okay, Kingsley said, sir, I do understand. Now, if you did understand, whip this one come. Yes or 2K? Alright, or 2K. Okay, whip this one come, whip this one come. Oh yeah, oh yeah, oh yeah, oh yeah. Wash your screen. Wash your screen. Identify this one. Oh yeah, oh yeah. Tin. I'm waiting. Oh ye that said I understood. Oh yeah. Whip and come. I dey wait to. Okay, someone said, can you guys still hear me? Can you guys still hear me? Please, if you can hear me, indicate. Alright. So let's. Okay, okay. I'm glad. I'm glad. Alright. So, ladies and gentlemen, let's name it again. Let's name. Okay, let's do it together. You guys tried. I'm impressed. I'm impressed. Let's keep it up. Keep it up, guys. Keep it up. Keep it up. Keep it up. Yeah, I'm super glad, guys. Now, the difference between you and those people sleeping right now is that you have a target. You want to pass this jam. So, if you are new to this channel, subscribe. Oh. Subscribe. Alright, subscribe. We'll still be here for you in your pursuit, hear me. Subscribe. Now let's do it. What is rule 1? What did rule 1 says? Rule 1, in case you have forgotten. Rule 1 says identify the longest chain, right? That's what we're going to do right now. What is the longest chain here? We have 1, we have 2, we have 3, and we have 4. Now, the longest chain is 4. What is 4? What is 4? Let's come back to this table quickly. 4 is boots. 4 is boots, right? 4 is boots. So this is boots. The second thing is to identify the functional group. What is the functional group, ladies and gentlemen? Are these hydrogen atom, are they joined by single bond or double bond? Ladies and gentlemen, they are joined by single bond. Because it is single bond, it is alkane. Are you seeing the way I'm analyzing it? So therefore, I can say this is boots, right? If I combine A and B together, I say it is butane, right? This is butane. Now, what is now the substituent? Remember, the substituent is anything that is attached to it, right? So if you look at this place is supposed to be hydrogen, but now we are having bromine. So let's now count now. This is 1, 2, 3, 4. So let's count from bottom. We have 1, we have 2, we have 3, and we have 4. Now, bromine has two positions, position 2 and position 3. Now, I now ask you, which of them is the smallest? Remember, we are always concerned about the smallest. You will tell me that the smallest is bromine. Sorry, the smallest is number 2, right? So therefore, I can simply say this is 2. This is 2 butane. In this case, okay, so for this case, I'm simply saying that we have bromine at the position 2. Bromine is at the position 2, right? Bromine is at position 2. What is the parent name? That is the number of carbon plus the functional group is stand. Do we understand? Let me know. Do we understand? Do you understand? Do you understand? All right. So moving forward, this is this is just like a proper representation. Yeah, I drew it very well, right? So we have 1. Okay, let me use another color. So we have 1, we have 2, we have 3, I have 4, right? So you can see that at position 2 we have the ocorobromine here, right? So this is 2 bromo 2 bromo butene. Okay, I'm not writing this very well, but you get the point. You get the point. All right, so let's proceed. Now, if you understood what I did, please give me the name of this structure. Oh yeah, name this for me, my guys. I know you can see it very well, even if it's a bit rough, but I'm convinced you can see it. So name this for me, ladies and gentlemen. I'm waiting. Name for me. So if you are new to this channel, do well to subscribe. Subscribe. Yeah, do well to subscribe to this channel. We give out quality. We give out quality. So sorry for the network the other time. We almost canceled this class. Yeah. So 2-chloropentane. A lot of people are saying 2-chloropentane. Okay, let's see if that is correct. What do we do? Firstly, we count. So let's count. Okay, so if we count from bottom, we see that the longest chain is 5, and that is pet. That's pet. Very correct. So what is the functional group? The functional group is a single bond, and that is alkane. So alkane plus pet, that's pentane. Now the next thing we'll do is to count the substituent. What is the substituent? The substituent is this, right? So let's count from the side that is closest. So we can decide to leave it from here. 1, 2, 3, 4, 5, right? 5. So let's pick the smallest. Smallest is 2. Ladies and gentlemen, you guys are correct. So it is indeed 2-chloro pentane. I'm glad. Siona Sisona don't they understand that now. We are naming it. Ladies and gentlemen, there's a part 3 of this class. When I know the name small small. So what if, to ensure that you guys are not cramming, what if I change the position? What if I change the position, guys? Okay, give me this name now. Okay, give me this name now, guys. So please do this for me right now. Time up. Time up. Can you guys hear me? It's time up. There's sand, oh, there's sand. When I too like sand. There's sand, please. Okay, let's continue now. Now, we've just looked at just three rules. We look at rule one, we look at rule two, we look at rule three. So all this naming that you guys have been naming, you just apply rule one, rule two, rule three. So ladies and gentlemen, it is high time we look at rule four. Alright. Now in rule four says that if the substituent, remember substituent is that thing that branch. If the substituent is more than one times in a molecule, the number of the substituent is indicated by the prefix. What is it, ladies and gentlemen? So the prefix we have one stand for mono, two stand for di, three stand for tri, four stand for tetra. So we'll stop there. So I repeat, rule 4 says that if the substituent is more than one times, right, in the molecule, then we use a prefix. We use a prefix. Now let's look at an example of a compound like that. So this is a good example, ladies and gentlemen. Now in this example, remember, don't forget your first and second rule. And what's your first rule? Identify the longest thing, right? So we have one, we have one, we have two, we have three, we have four, we have five. So five is spent. Five is spent. You remember? Five is spent. Hope you remember. Hope you remember that five is spent. Right? Now, what is the functional group here? What is the functional group? Of course, the functional group is alkane. The functional group is alkane. So now let's combine one or two. So if we combine one and two, we have pentene. Guys, hear me now. I'm back. I'm back. So can you hear me now, guys? Can you guys hear me? No. All right. So Can you guys see my screen? Can you guys see my screen? Alright, so it is assumed that you guys can still hear me. So please, if at any point you can't hear me, please don't hesitate to comment, alright? Our enemy is trying to stop us tonight. Okay, so let's proceed. Um, so like I said, that if we combine rule 1 and rule 2 together, right? First of all, we count the number of carbon atoms, and we see that we have 1, 2, 3, 4, 5. So it is 5 here. That tells us that it is pent, right? What is the functional group? What joined them? Join these carbon atoms together. Of course, it is a single bond, and that makes it alkane. So if you combine pet and alkane together, what you have is pentane, right? Now, this pentane you have is known as the parent name. Now, let's now work on the substituents. What are the substituents? These are the substituents, right? These are the substituents. Now, we have 1, 2, 3, 4, 5. So let's liberate now. We have 1, 2, 3, 4, 5. We have one. We have two. We have three. We have four. We have 5. So I ask you a question. Which of them is closer? If you count from the up or the down. So if you count from the down, of course, 2 is the closest. So that will make us to have. Okay, let me clean this first. So that will make us to have something like this. 2, it means that at position 2, we have this. And then also position 3, 2, 3, di. Remember, 2 is di. Di, bromo, pentane. I hope I'm not shouting, sir. I hope I'm not shouting. So this compound, what we have here is 2, 3, di, pentane. Do you understand? Please. If you did understand what we just did, you understood what we just did, comment that you understand, you're following. Let me know, let me know, let me know, because the next now will give you a compound to identify for me. Okay, Luma said, do you understand? Matthias Beatrice, did you understand? Um, Joy, um, Perfecto Diamond. You have to be sure. Um, understood. Okay. So here's Mr. Bliss. All right. So majority said they understood. So let's do this now. Okay, Marvin Young, Gabriel. Okay, let's do this now. Yo, can you name this compound for me? If you can, Lost in Precious. If you can, comment I can. If you want us to do it together, comment. Let's do it together. Loss in pressures. Loss in pressures, are you a PTS student or Jambite? I'm waiting. Okay, Splendid said I can. Gutter said I can. Joy said I can. Okay, oh yeah, we can come. Ah, 233 dimethyl ethane. And Lumas, please look at your prefix very well. Look at your prefix very, very well. Perfect. Diamond said let's do it together. Right, sure, we're gonna do it together, but let's give let's give others 3 minutes to respond. 3 minutes. You can see pin there. Yes, Kingsley. Yes, Kingsley. Kingsley or 2K wisdom. Okay, Francis said it is 233 trimeter ethane. Lost impressions. Lost impressions. Are you PTS or John Bright? Alright. Kingsley said it is 2 3 trimeter ethane. Okay, let's do it together. Okay, let's do it together. Let's do it together. Guys, I hope you are enjoying this class. Sorry, the network is really up and down. But if you are new to this channel, please like and subscribe. Right? I hope you are enjoying this class. Let me know, let me know, let me know. Let's do it together. So, the first thing we do, rule 1 and rule 2. Rule 1 says identify the longest, right? The longest. Rule 1 says identify the longest. So, we're going to do just that. So, what is the longest? We have the longest. We have this. One, two, three carbon, four carbon, five carbon. Okay. I think let me number. We have we have one carbon, we have two carbon, we have three carbon, four carbon, have five carbon, we have six, right? Let's go one, two, up and down, three, four, we have five, right? And have six. Now, with this, I know obviously that my longest is 6, and 6 is equals to x. Hope you guys remember that. 6 is equals to hex. Watch your screen. 6 is equals to x. Now, what is the functional group? Right? Which is root 2. What bind these hydrogen atoms together? Now, what binds them together is a single bond. Now, you can see that it is a single bond that bonds them together. So, because it is a single bond, this is alkane. Single bond is alkane. We look at these rules, right? Single bond is alkane. Now, if we combine 1 and 2 together, which is X and alkane together, we have ethane. Its name is ethane, right? Okay, let's now do for rule 3. Now we have ethane here first. Now, what is if we have a substituent? We should count in the way we ending. So, for example, now if I should start counting from here, I hope I'm not shouting, sir. If I should start, I can still count from. I can count from bottom. I can count from up. Now, if I count from left to right, I have the first substituent. This is the first substituent, right? And if I count from up, which is right to left, this is the first substituent. And the first substituent is at position 4. From right to left, then from left to right, the first substituent is at position 2. So I ask you, 2 and 4, which one of them is bigger? Of course, it's 4, and 2 is the smallest, and the smallest is what we consider, right? So automatically, we now have, or we now say that this is at position 2. So this is 2, comma, position 2. Then the next one is position 3, right? So at position 3, we have up and down. Position 3, we have up and down. So we will now say this is 2, 3, another 3 again, 2, 3, 3. Since it is 3 methyl we are not looking for, is now tri, which is the prefix, then methyl, methyl, pentane, methyl ethane. Do you guys understand it? Yeah. So it is 3 methyl ethane. Perfecto. Do you understand? Who else don't it understand this? So now I know majority of you have already know name it. So can I give you one now? I will not say anything. I'll just off my mic and be looking at you guys. Can I give you one now? If you are ready, say I am ready. If you are ready, say I am ready. All right. Now, name this one for me. Name it for me. Um, I'm not gonna get mad if you name it wrongly. I just saw something. I'm not gonna get mad if you name it wrongly. Or let's see if I can make a correction to it. Um, yeah, guy, please name this for me. Watch your screen very well, oh. No go carry rush, oh. Watch your screen very well. Um, Matthias, Matthias Beatrice, please watch your screen very well. Um, Splendid Light, please watch your screen. I'm waiting, oh. Why are people not attempting it? Or to watch your screen very well. There's no plural there anymore. Where is Mr. Bleeze? Where is Faith? Where are you all? Okay, I'm giving people like 2 minutes or 3 minutes to answer. Now, what's the first thing we do? the first thing to do is to identify the longest carbon atoms, right? Which is row 1. So this is 1 carbon atom, no, 2, 3, and this is 4. Or let me use another color. Let's say this is 1 carbon atoms,